In our foldable, I asked you guys to graph the parent function. Class, give me the coordinates for the parent function. 0, 0. And the other side? So there I have y equals x squared. Okay. Yesterday's lesson is we did something like this, right? And if we said it was greater than 1, where's my graph going in terms of the parent function? Inside or outside?
Inside.
Inside. So let's go ahead and graph green. Inside. So I need a number that's bigger than 1. Can someone give me a number that's bigger than 1?
3.
Thank you.
1.
Y equals 3x squared. We kind of talked about yesterday, it's kind of like money. You know, if you have an interest rate that's 3 or higher, your money's going to go up faster, so it actually makes your graph look skinnier. Okay? Another example that Mr. Frank and I were talking about is if my children run to me, right? I might pick them up by their arms and swing them. So they're not strong enough to do what gymnasts do, right? Gymnasts have the perpendiculars. But what would happen to their arms if I took them by the wrist and I picked them up? What would happen? What would happen to their arms? The arms would get what? The arms would get closer or skinnier. Okay? Now, if your number is between 0 and 1, so think about money. Between 0 and $1, like a fraction or decimal, what's going to happen to our graph? It gets wider, right? So let's draw a graph. Someone give me a number between 0 and 1.
0.
Something like 0.08. Yesterday we learned, what are some other words about that's vertically stretching? We talked about, someone said thinner. I like that. How about narrower? Skinnier, shrinks. In class, how about compresses? Wider and shorter. Mr. Frank and I were talking about how it was hard to show you a visual, so it's kind of like a cartoon. Pretend the building is falling, and then kind of just squishes from the black to the pink. Okay?